morning. We're going to be working on long division of polynomials today. So one of the things that you do when you're doing long division of polynomials, if it's written this way, we're really going to be changing it to be written in a long division form. So we're divided by x minus 2. We're dividing into x squared minus 7x plus 10. So this is a little long. When I do this division, I look at the first term and I ask myself, what would I have to multiply times x to get the first term here, x squared? The answer is x. So I put an x above there. And then I multiply the whole thing times x and write it underneath. X times x is x squared. X times negative 2 is negative 2x. Now, in normal division, when we do this, we subtract. Well, we're going to subtract here, but we have to make sure we're subtracting this whole thing. So I put parentheses around to remind myself that I'm subtracting this whole thing. I need a little bit of room here. I want to shift that over. There we go, that's better. All right, so x squared minus x squared. Anything subtract itself, 0. Now, I'm going to write out the next subtraction. Negative 7x minus negative 2x. I write it out because I want to make sure that I am not forgetting any sign and not making any sign errors. Subtract the negative, add a positive. That ends up as a negative 5x. I'm going to bring everything else straight down and repeat the process. What times x gives me negative 5x? Negative 5. Now I multiply the negative 5 times x minus 2. Negative 5 times x, negative 5x. Negative 5 times negative 2, positive 10. When I do the subtraction here, negative 5x minus negative 5x cancels out. 10 minus 10 cancels out. I have nothing left over, so my answer is x minus 5. Let's take a look at another example. Here we go. I'm going to go ahead and write this out. X plus 2. Inside, I'll put 4x squared minus x minus 1. Again, I ask myself, what do I multiply times x to get 4x squared? 4x. 4x times x, 4x squared. 4x times 2, positive 8x. I'm going to be subtracting this. And when I do so, 4x squared minus 4x squared cancels out. Negative x minus 8x. That's going to give me negative 9x. And then I bring the minus 1 straight down. Now I'm going to repeat the process. What times x gives me negative 9x? Negative 9. Negative 9 times x, negative 9x. Negative 9 times 2, negative 18. Again, I'm going to subtract. Negative 9x minus negative 9x cancels out. That one's gone. All right. Negative 1 minus negative 18. That's going to make a plus positive. So that's going to give me positive 17. So now what I do when I get to this point is this is the remainder because there's nothing I can multiply times x directly that's going to give me 17. So I just put plus the fraction, and the top of the fraction is your remainder. And the bottom of the fraction is x plus 2. And there is our answer. Now some books will say this is the quantity q, I think they use, or q of x. and they call this part alone r of x, the remainder. I think it's easier just to write it as this form, because if I actually distributed x plus 2 times this, I would get this back. All right, here's our next example. 2x minus 3 inside 2x squared plus 7x minus 10. 2x times x gives me 2x squared. 2x squared multiplying minus 3x. Again, I'm going to subtract. These cancel. 7 minus negative 3. 7x minus negative 3x plus positive, that'd be 10x. Bring this down, minus 10. Repeat the process. 2x times 5 would give me 10x, so plus 5. 5 times 2x is 10x. 5 times negative 3, negative 15. Again, I have to subtract that. The 10x's cancel. Negative 10 minus negative 15. Again, that's plus positive, so that gives me positive 5 down here. So then I can add 5 over 2x minus 3. Remainder over divisor. Next example. All right, this one is interesting, and you'll ask yourself a question. Here we go. 2x minus 3. I'll show you what I mean. You may say, why are you doing that? 8x to the third minus 27. You say, why did you put it way over there? That doesn't make any sense. Here's why. I'm going to put 0 value placeholders wherever there's a missing term in descending order here. So like I have 0x squareds and 0x to the first. And you may ask yourself, why are you bothering to do that? That doesn't seem to help you at all. Give it a second. What times 2x gives me 8x to the third? 4x squared. When I multiply 8x to the third, everything's good. When I multiply here, negative 12x to the second. Notice like terms are right above each other. If I had put that right under here, some of you might have made the mistake of trying to combine the negative 27 and the negative 12x squared. They're not like terms. We can't combine them. But some people make that mistake. So keep like terms above each other. This is just a placeholder. I'm going to combine straight down. This cancels. 0 minus negative 12 is positive 12x squared. I'm going to bring this straight down and this straight down. I'm just going to put plus 0x minus 27. Let's repeat the process. 2x times 6x gives me 12x squared. Multiply 6x times 2x, 12x squared. 6x times negative 3 is negative 18x. I go ahead and subtract. The 12x squareds cancel. 0x minus negative 18x. I should put plus positive. That's 18. So that gives me 18x minus 27. Last step in the process, 2x times what gives me 18x? That's going to give me a positive 9. 9 times 2x is 18x. I'm going to have to move this up, running out of room. Not that far though. There we go. And 9 times negative 3 is negative 27. Please notice that worked wonderfully. These cancel, no remainder. There's my answer. Now some of you may have noticed early on that this is difference of cubes. You also may have noticed that 2x cubed gives you 8x to the third, and 3 cubed gives you 27. So that would be the first parenthesis when we factor difference of cubes, and this is the second parenthesis. But you may not have noticed it, and it gets you the same end result. All right, let's take a look at our next example. Here we go. Now, in this example, it's a little bit interesting. I'm going to have a lot of room here. 3x squared minus 5. Now, I did not put a placeholder here, but when I do put them in here, you're going to have to put them under like terms. So let's see how that looks. 6x to the 4 minus 12x to the third plus 11x squared plus 20x minus 35. That's a lot. Let's see how it works. What times 3x squared gives me 6x to the fourth, 2x squared. When I multiply, 6x to the fourth. When I multiply here, that's going to be negative 10x squared. So that's where I want to line it up. I have, these two cancel out. Negative 12x to the third minus nothing is still negative 12x to the third. 11x squared minus negative 10x squared give me 21x squared. And then just bring the others down. This is technically just brought down. All right. Repeat the process. What times 3x squared gives you negative 12x to the third, a negative 4x. Multiply them. Negative 12x to the third, positive 20x. All right. These cancel. These cancel when we subtract. I'm just going to bring this straight down because it has nothing to subtract with. I'm going to bring this down. And you could put a 0x squared, but because we're missing one each time, we're probably going to miss it again. If you want to, you could put that 0x squared in. Let's check it out. What times 3x squared gives you 21x squared? Well, 7. 21x squared, 7 times 3x squared, 7 times negative 5, negative 35. I'm going to subtract, and I will have no remainder here. So my final answer is 2x squared minus 4x plus 7. And that's the end of the lesson for today. I hope that helped you.